The phenomenon in which the passage of current through an electrolyte, whether molten or in solution, brings about chemical changes involving electronation as well as de-electronation, also known as oxidation of ions, is known as electrolysis. If an electrolytic solution consists of more than two ions and the electrolysis is done, it is observed that all the ions are not discharged from the electrodes simultaneously, but certain ions are liberated from the electrodes in preference to others. This is explained by the preferential discharge theory. It states that if more than one type of ions are attracted towards a particular electrode, then the one discharged is the ion which requires the least energy. The potential at which the ion is discharged or deposited on the appropriate electrode is termed the discharge potential or deposition potential. The values of discharge potential are different for different ions. Following are some examples of preferential discharge theory. Now, in the upcoming illustration, we'll determine the charge in coulombs on 1 gram ion of N³-. To calculate the charge on a single ion, we simply multiply the number of electrons by the charge of an electron. According to Avogadro's law, 1 gram of ions contains a staggering approximately 6.02 times 10 to the power of 23 ions. So we can calculate the charge on 1 gram ion of N³ by multiplying the charge on one ion by Avogadro's number. Let's break down the calculation. The charge on one ion of N³ is approximately 3 times 1.6 times 10 to the power of minus 19 coulombs. 3 is the charge, and 1.6 times 10 to the power of minus 19 C is the charge of one electron. Now, using Avogadro's number, 1 gram ion equals approximately 6.02 times 10 to the power of 23 ions. Therefore, the charge on 1 gram ion of N³ is determined as follows. Approximately 3 times 1.6 times 10 to the power of minus 19 coulombs charge on one ion times approximately 6.02 times 10 to the power of 23. This simplifies to approximately 2.89 times 10 to the power of 5 coulombs. So the charge on 1 gram ion of N³ is approximately 2.89 times 10 to the power of 5 coulombs. Now, in the next illustration, we will delve into two chemical reactions and explain the role of oxidizing and reducing agents within them. In chemistry, redox reactions involve the transfer of electrons between different chemical species. One species undergoes oxidation, loses electrons, and is therefore considered the reducing agent, while the other undergoes reduction, gains electrons, and is regarded as the oxidizing agent. Let's analyze the reactions. In this reaction, Cl2 acts as the oxidizing agent. It accepts 2 electrons and transforms into 2 Cl-. Meanwhile, I- undergoes oxidation, releasing 2 electrons, which combine to form a 2. Therefore, Cl2 oxidizes I-, and it serves as the oxidizing agent. In this case, I2 serves as the reducing agent. It gains 10 electrons to form 2 I- ions. At the same time, Cl0 is oxidized, releasing 10 electrons, which combine to produce Cl2. Hence, I2 acts as the reducing agent in this reaction. In redox reactions, it's crucial to identify the species that undergo oxidation and reduction. The species undergoing oxidation functions as the reducing agent, while the one undergoing reduction acts as the oxidizing agent. Understanding these roles is essential for comprehending chemical reactions and their mechanisms.